Learning objectives. In this chapter, the user will be learning about advanced features using C# and the following in detail: web services, Windows services, messaging, reflection, COM and C#, localization, distributed application in C#, XML and C#, unsafe mode, graphical device interface with C#, case study, messenger application. Web services. A web service is a network accessible interface to application functionality built using standard Internet technologies. A web service is a distributed computing technology that enables the exposure and reuse of logical business entities over the Internet. Creating ASP.NET Web Services is incredibly easy. ASP.NET Web Services are web services supported by the ASP.NET infrastructure. Several open standards technologies play a significant role in making web services a reality. These standards can be categorized by description, discovery, and transmission. The Web Services Description Language, WSDL, is an XML-based format for describing a web service. It describes what the web service is, its parameters, and how to use it. Universal Description Discovery and Integration, UDDI, directories support discovery. These directories manage WSDL documents and provide a means for clients to find and use web services. The Simple Object Access Protocol, SOAP, is a communications protocol that enables clients to interact with UDDI directories and web services. Viewing web service info. The ASP.NET infrastructure provides the means to view information and test the operation of a web service. To do so, point your browser to the location of the web service on a web server. Figure shows the results of pointing a browser at a web service. Using web services. If an application wraps a method call into SOAP envelope and uses HTTP, it could use those methods to communicate with a basic web service. Alternatively, the client could use one of the HTTP GET or POST methods. It's possible, but that would be a lot of work. The .NET framework comes with a utility called WSDL that frees the client from creating all this plumbing. This utility takes the URL to a web service and creates a proxy, which is used by the client to call the web service. Using a web service requires a client to declare an instance of the proxy class and then call the necessary web service operation defined in the proxy class. Web services provide a platform-independent means of exposing business logic over the Internet. They are created using several open standards technologies. Creating ASP.NET Web Services is easy and abstracts much of the complexity associated with Internet communications. This allows developers to concentrate on business logic rather than underlying plumbing. Use of a web service involves creating a proxy class that communicates with the web service on behalf of a client. The client application then communicates directly with the proxy to invoke necessary web service operations. Windows Services. Visual Studio has supported Windows Services projects since .NET 1.0. To create a Windows Service project, select File, New, Project, select the Visual C#/Windows branch of the navigation tree, and then select Windows Service. The Windows Service project contains a couple of items that are unique. This section explains what they are and how to get the codes, which are created on a new Windows Service project. Notice that there aren't any spaces in the name of the project. Default spaces don't work with Windows services. A Windows service consists of method overrides that you implement to make your service work. The code for a service has several overridden methods corresponding to the events of a service, such as start, pause, continue, and stop. To implement onStart and onStop, the wizard provides a step-by-step creation within the shell code for creating the Windows Service project. To view the code for the Windows service, either select the blank design surface or the Solution Explorer file for services 1.cs, right-click and select View Code. Implementing Windows Service method overrides. Implementing onStart and onStop. The method overrides in a Windows service to get your program to work. The onStart and onStop methods are shown here as minimal implementation. The onStart method can be called when the OS boots and starts services marked as automatic. It can also be called manually via the Services console that you can find via your OS Administrative Tools panel. The onStart method of a Windows service has a total of 60 seconds to complete. To avoid timeout, you can launch running processes on a thread, which enables the onStart method to finish on time. Installing a Windows service. The installer has two parts: a service process installer and a service installer. The service process installer configures a service installer. The service installer provides setup for individual services, meaning that you can have multiple services running in the same process. Select the service process installer and open the Properties window to configure it. The most important property to set is Account. The available settings are one of the service account enums values. The most configurable option is User, where you can give the service a machine or domain account. Controller to communicate with a Windows service. Control a Windows service from a separate application. SQL Server Taskbar app is a good example. The example we use is a WPF application. So if you're following along, create a new WPF application and add a couple of buttons to the window with content properties set to Start and Stop, and with name properties set to Button Start and Button Stop respectively. Messaging provides access to the properties needed to define a messaging queuing message. Inheritance hierarchy. System.object, System.MarshallByReferenceObject, System.ComponentModel.Component, System.Messaging.Message. The message class provides fine control over message properties to determine sending of messages in a queue and peaking or receiving. Message queue uses the message class when it peaks or receives messages from queues, because both the message queue.peak and message queue.receive methods create a new instance of the message class and set the instance's properties. The message class's read-only properties apply to retrieving messages from a queue, while the read or write properties apply to sending and retrieving messages. The message queue class's send methods allows you to specify any object type for a message being sent to that queue. You can use the message queue's instances default properties to send property to specify settings for generic messages sent to the queue. The type of settings include formatter, label, encryption, and authentication. You can also specify values for the appropriate default properties to send members when you coordinate your messaging application to respond to acknowledgement and report messages. Using a message instance to send a message to the queue gives you the flexibility to access and modify many of these properties, either for a single message or on a message-by-message basis. Message properties take precedence over default properties to send. Message data is stored in the body property and to a level. Reflection. Reflection objects are used for obtaining type information at runtime. The classes that give access to the metadata of a running program are in the System.Reflection namespace. The System.Reflection namespace contains classes that allow you to obtain information about the application and to dynamically add types, values, and objects to the application. Use of reflection. Reflection has the following uses. It allows view attribute information at runtime. It allows examining various types in an assembly and instantiate these types. It allows late binding to methods and properties. It allows creating new types at runtime and then performs some tasks using those types. Viewing metadata. Using reflection, you can view the attribute information. The member info object of the System.Reflection class need to be initialized for discovering the attributes associated with the class. To do this, you define an object of the target class as System.Reflection.member.info. Info equals type of my class. C# reflection. The following program demonstrates this. When it is compiled and run, it displays the name of custom attributes attached to the class myClassHelp attribute. COM and C#. Communicating with COM. One of the most likely interop scenarios is communicating from .NET to existing COM components. This can allow preservation of existing infrastructure and reduction in overall development cost. COM components may be called via either early or late binding. Via early binding, legacy COM components can be made to appear as managed objects in the .NET environment. This is accomplished by a utility that reads an existing type library and creates a proxy for the .NET component to interact with. Early bound components are those that are bound at compile time. This promotes type safety and improves the program's overall performance. Early bound COM component calls. Select File, New, and then the project. When the project window pops up, select ATL project and name it COM obj.dll. The IDE will build a skeleton with many files. From the Solution Explorer window, right-click, select Add Class. When the wizard pops up, select ATL control and name the component com4.net. This creates a class named ccom4.net and an interface named icom4.net. After the ccom4.net class has been created, go to the Class View window and right-click the icom4.net interface. Select Add Method. When the wizard pops up, name the method getResponseFromCom with no parameters. Go to the ccom4.net class, where the getResponseFromCom open close brackets method shell is defined, and add the contents. This completes creation of the COM component necessary for this example. The .NET framework to create a proxy for the COM component. Output: Hello from COM. The proxy is then compiled into the C# program. The COM component can be instantiated and called just like any other managed component. Late-bound COM component calls. When a type library isn't available, there's a dynamic invocation requirement. C# program can perform a late-bound call to a COM component. Late-bound COM component invocations are performed using C# reflection. It first obtains prog ID from the COM object as listed in the Windows registry. When a type object is obtained, an object is created using the static createInstance method of the activator class. The getResponseFromCom method of the COM component is then invoked with the invokeMember method of the type object late-bound type. Exposing a .NET component as a COM component. A C# component exposed as a COM component. Call from com.dll. C# components are accessible as COM components. The .NET Framework tools create an unmanaged proxy. Apply proper settings in the registry. This enables unmanaged code to use .NET components as if they were COM components. This command line registers the C# library as a COM component. In addition, the /TLB operation creates a type library to facilitate early binding. To generate a type library without registering the library, use the TLB exp program as shown in the following command line. Calling a C# component exposed as a COM component. AVB program calling a C# COM component. A message box showing the response from a C# COM component. Introduction to .NET support for COM plus services. The .NET Framework provides extensive support for COM plus services such as transactions, JIT activation, object pooling, and others. COM plus services are activated through the use of attributes which decorate a specific C# element as appropriate. These attributes are analogous to the COM plus concepts. The other step necessary to make the C# program work as a COM plus service is to register it. The application name attribute identifies the COM plus name, and the assembly key file attribute specifies the strong name key to register the assembly with. Following command line shows how to create a strong name key. Transactions. A transaction is a way to combine multiple actions into a single body of work to guarantee that all actions either succeed or fail together. C# program can participate in COM+ services transactions by inheriting from the COM+ services class and marking their classes with a transaction attribute. Another transaction-related attribute is autocomplete, which enables a transaction to commit automatically if all items succeed. However, if an exception is raised, autocomplete causes the transaction to abort. JIT activation. Just-in-time JIT activation is the capability to instantiate a new component. Components go away automatically when they are no longer needed. By using COM+ services and associated attributes, a C# component can participate in a JIT activation. Implementing JIT activation requires specifying the just-in-time activation attribute. JIT activation is true by default, but if you want to turn it off, specify false as a first attribute parameter. Object pooling. Another COM+ service enabling efficient use of resources is object pooling. An object pool is a group of components that stay activated and ready for connection at all times. This reduces the overhead associated with the activation and deactivation of components. The object pooling attribute has three parameters: enabled, min pool size, and max pool size. The enabled parameter turns object pooling on. The min pool size parameter specifies the minimum number of objects held in the pool, and the max pool size parameter specifies the maximum number of objects to be held in the pool. Other services. COM+ services include several other technologies such as roles, security, and message queuing. Using the techniques described in other sections and examining the applicable attributes in the System.Enterprise Services namespace. C# and COM+ services security are mutually exclusive. Localization. Resource files. Setting up and using resource files is a primary means of localizing programs. Resource files are specialized binary files that can be bound to a standalone DLL or added into a program assembly. They contain strings, graphics, and other binary resources that assist in localizing a program. Creating a resource file. The Resource Generator utility, ResGen, is a string resource creation utility that comes with the Microsoft .NET Framework SDK. Given a properly formatted .txt text file, ResGen converts it into a .resources binary resources file that can subsequently be added to an assembly. Without a special resource creation tool, string resources begin life as a specially formatted .text file. They have headers, comments, and name-value pairs. Header elements must match the file name without the extension. For example, if the resource file's name is myresources.txt, the header contents must be myresources. Comments are useful for delimiting groups of resource strings or adding more information to the use of a string. All comments are removed from compiled resources. Writing a resource file. Resource files may be created programmatically. This is useful for automated .resources file generation utilities or resource tools in IDEs. The steps involved in creating a .resources file are to open a resource writer stream, add whatever resources are needed, and then close the stream. The default resource writer class in the System.Resources namespace implements iResourceWriter. This is why it is possible to create an iResourceWriter object within the main method of the resource writer constructor. It accepts a string parameter specifying the resource file to create. If a file by that name exists, it will be overwritten. Reading a resource file. The resource reader class is also useful in creating resource manipulation utilities and IDE tools to manage resources. A utility uses the resource reader functionality to read in an existing resource file. The program performs any necessary manipulations and then the resource writer helps write the new resources back to the persistent .resources file. Converting a resource file. Another use of ResGen is to convert between .txt, .resources, and .resx files. REXX files are XML format files used for binary resources such as graphics, fonts, icons, and cursors. For example, the following command line converts the .resources file to a .resx file. ResGen strings.resources strings.resx. This produces an XML format file. The same exact file would have been generated if you had performed the following command line: resgen strings.txt strings.resx. Creating graphical resources. The .NET Framework SDK includes a couple of sample programs that help manage graphical resources. One is the RESX Gen program, which adds a graphic file to a .resx file. The RESX Gen utility, the RES Editor utility. The other is the RES Editor program, which manages all types of resources for .resources files. Using graphical resources. An added bonus is that these two utilities come with the source code, enabling you to examine graphical resource manipulation code in detail. Multiple locales. The purpose of resource files is to support multiple locales. The official way of specifying locales is via cultures, as specified in RFC 1766, ISO 639, and ISO 6133. Cultures are denoted with 4-character designations. The first 2 characters specify the language in lowercase, and the second 2 specify the country or region in uppercase. A separate resource file must be created for each locale. There are multiple ways to deploy these resources: compiled into a program, via satellite assembly, or via global assembly. Multiple locales. Through a combination of resource files and a directory structure geared toward targeted cultures, any program can be localized. The directory structure corresponds to each culture implemented in a program. The following directory structure supports localization for a program named multiculture: EN, ENUS, ENGB. If the appropriate culture subdirectory is present, a localized program can automatically pick up the resources corresponding to its default locale. Finding resources. Search the global assembly cache for the specific resource. The global assembly cache functions as a central repository for all programs on a machine to access. Search culture subdirectories of the localized program. Search the global assembly cache for parent resources. For instance, if the original resource selected but not found was an ENUS, search the global assembly cache for EN only. Search culture subdirectories of the localized program for the parent resources. Search culture subdirectories of the localized program for parent resources of the last parent resource searched. A resource has only a single parent, but the chain of parents can extend to multiple levels. Distributed application. Remoting is an infrastructure that allows a developer to use remote objects. Remote objects are objects that are based or instantiated outside of the caller's application domain. This example shows you how to use both remote objects access mechanisms, pass-by values, and pass-by reference. It also shows you the power of remoting for distributed computing with a simple yet powerful implementation of a task server. Basic remoting. Remoting is the capability to communicate with components in separate app domains. Figure shows a simplified view of 2 objects communicating via remoting. A client component in app domain A communicates with a server component in app domain B. An app domain is an execution environment within a process. It separates managed applications during execution. This provides several benefits, including reliability and security. Remoting supports multi-tiered as well as distributed architectures. The server component in app domain B could easily be extended to a client role, communicating with a server component in another app domain. Furthermore, a remote component could be located in another process on either the same or a different machine. When a component is set up, the underlying plumbing required to maintain remote communications is hidden by the remoting architecture. There is a server, which is a DLL that must be hosted by another application, either IIS or a custom host that you built. There is also a client, which is an executable that makes an outer process call to communicate with the remoting server. Now we shall see how to build the remoting server first, and then the client, and finally a couple of ways to host the server. After the server is hosted, the host begins to run. Remoting server. A remoting server object is just a class that derives from Marshall by reference object. The basic server class inherits Marshall by reference object, which supports the basic functionality for a callable component over the remoting architecture. This class is implemented as a DLL, negating the need for a main method. The only method in this class is the getServerResponse method, keeping things simple. Each remoted component requires a configuration file named web.config to specify necessary operating parameters. Remoting client. Writing a remoting client is just a little more involved than writing a remoting server. Writing a client requires finding out the type and location of the remote server object, initializing configuration from a file, and creating an instance of the remote object with the type and location information obtained earlier. The system.runtime.remoting namespace contains all the basic remoting classes. Our remote server component that will be instantiated and called is in the basic server namespace. Within the main method, the type of the basic remoting server class is obtained with the type of operator and stored in a type object. Next, the URL of the basic remoting server. Remoting setup. There are two ways to get a remoting application up and running: via a web server or a host utility. Use Microsoft Internet Information Services (IIS) as a web server to host the remote server component. Web server setup. Demonstrating the host utility requires code for a new client and server program and the utility. The following steps show how to set up a remote server component via the IIS web server. Before actually starting the procedure, work out a directory structure so that it will be easy to follow along. Here's what your directory structure should look like. Compile the server component from the basic server directory with the following command line. Open Internet Information Services (IIS). The following steps work for Windows XP but are different for other operating systems. For example, WinNT, Win2K, Win2003, Win2008, and Vista are all different. If the actions don't match your OS exactly, consult your documentation to accomplish the same tasks. Expand the server node under which you want to create a virtual directory and right-click Default Website. From the menu, select New Virtual Directory. This opens Virtual Directory Creation Wizard. Click Next. In the text box for an alias, type in any meaningful name for the virtual directory, such as Basic Server Demo. Click Next. In the text box for the physical path that the virtual directory will refer to, enter the open tag path close tag / basic server directory, where open tag path close tag is the actual directory you specified in step 1. Click Next. There are several access permissions from which to choose. The read and run scripts such as ASP options are already checked, and that's fine. Accept the defaults, click Next, and then click Finish on the last screen. IIS will use the web.config files in the basic server directory when it loads the server component. The remote server component is now set up. Use the following command line to compile the remoting client program from csc /basicserver/basicserver.dll basicclient.cs optionally. Remember to add a reference to the basic server project. Right-click the References folder in Basic Client, select Add Reference, click the Projects tab, select the Basic Server project, and click the OK button. You'll also need to add a using declaration for the basic server namespace. Finally, run the basicclient.exe program in the basic client folder to test the system out. If all goes well, the following output will be printed to the console. Host utility setup. The following example illustrates host utility setup. Replace the basic server with hosted server and the basic client with the hosted client directory names. The host utility setup method uses a program that configures the remote server component. The process isn't necessarily easier or harder than the web server setup method. Channels marshal, format, and transmit messages across app domains. Each of a channel's tasks opens new opportunities for extensibility. For example, message contents can be marshaled to conform to the proper data representation using custom sinks. The message itself can be formatted via the built-in Sample Object Access Protocol (SOAP) or binary formatters. In addition, transport protocols such as HTTP or TCP, which are built-in, can be configured with ease. The architecture also supports customizable marshalling, formatting, and transmission components that can be plugged in as needed. The HTTP channel linking the proxy in app domain A to the stub in app domain B is a built-in channel component supporting default marshalling, XML/SOAP formatting, and HTTP protocol transmission. Lifetime management. A remote server component exists for a default amount of time and then makes itself available for garbage collection. It's often more desirable to explicitly manage the lifetime of remote components. This is why the remoting framework provides a leasing mechanism for finer granularity of control in remote component lifetime management. Remote leasing operates via a collaborative protocol between one or more client components, a server component, and a lease manager. Remote server components begin life with a designated amount of time before garbage collection. Client components register with the server component's lease manager for notification of when the server's lifetime is expiring. The lease manager keeps track of server components and notifies clients of when the server will expire. When a server has reached its expiration time, the lease manager notifies the client and waits for a designated amount of time for a reply from the client. If the client wants the server to remain alive, it returns the amount of time the server can live to the lease manager. If the designated reply time from the client to the lease renewal query expires, the lease manager marks the server object for garbage collection. Extensible Markup Language (XML). XML is an international standard which enables computer systems to communicate effectively. Applications can read and pass information with a common API. XML is an open standard that can work anywhere, regardless of your hardware platform, operating system, or programming language. XML permeates nearly every part of the .NET.XML class libraries to interact with XML data. It is the essential data transport format for web services, the format for configuration files, and the source of data from external systems. The .NET APIs make it easy to use XML as a standardized method of passing in programs, file saving and reading, data validation, and many other useful tasks. This chapter explains how to use C# and the XML class libraries to interact with XML data. Writing XML. Writing XML documentation is greatly simplified with the system.xml class library. The particular class used in this section is the XML text writer class. It has numerous convenience methods that make producing XML documents a snap. The .NET Framework documentation lists all the available methods for the XML text writer class. The XML streaming APIs encapsulate the code necessary to parse XML files and obtain data related to specific tags. Sometimes you need the flexibility of working with XML data in memory via the Document Object Model (DOM). Working with XML DOM. To work with XML in memory, you can use an XPath document and then use an XPath navigator to read each node efficiently. The difference between this technique and the XML text reader, in addition to what has been previously stated, is that an XPath navigator can move anywhere in the document, whereas an XML text reader is forward only. The task of modifying an XML document in memory requires using the XML document and XPath navigator. This is a common technique for making the code more maintainable because if the node name changes, you need only change the talk node constant. The second string parameter is the element value. There is no need for formatting because the writeElementString method calls to do it automatically. Unsafe mode. C# allows using pointer variables in a function of code block when it is marked by the unsafe modifier. Safe, unsafe, managed, unmanaged. The unsafe code or the unmanaged code is a code block that uses a pointer variable. Unsafe code permits the use of pointers, which support certain performance optimizations and interface to legacy code and operating systems. Unsafe code is identified with a special keyword, unsafe, which marks either a block of code or a field. This establishes an unsafe context where pointer operations can be implemented. The normal mode of operation in a C# program is safe. When code is safe, its type is safe and secure. Unsafe code is identified by the unsafe keyword. This is a code that is allowed to use pointers. All C# code is managed. Managed code is under control of the CLR, which has full control of all memory and security operations. A pointer is a variable whose value is the address of another variable, that is the direct address of the memory location. Like any variable or constant, you must declare a pointer before you can use it to store any variable address. You can retrieve the data stored at the location referenced by the pointer variable using the toString open close brackets method. You can pass a pointer variable to a method as parameter. The following example illustrates this. When the code was compiled and executed, it produces the following result. Pointer variables. When the code was compiled and executed, it produces the following result. Retrieving the data value using a pointer. When the code is compiled and executed, it produces the following result. Passing pointers as parameters to methods. Accessing array elements using a pointer. Compiling unsafe code. In C#, an array name and a pointer to a data type same as the array data are not the same variable type. For example, int star p and int open close brackets p are not same type. You can increment the pointer variable p because it is not fixed in memory, but an array address is fixed in memory, and you can't increment that. To access an array data using a pointer variable, as we traditionally do in C or C++, please check C pointers. You need to fix the pointer using the fixed keyword. For compiling unsafe code, you have to specify the /unsafe command line switch with command line compiler. Graphical device interface. The general framework that deals with the DC device context is referred to as a GDI, graphical device interface. In .NET, the GDI interface has been greatly refined and is referred to as a GDI+. The .NET GDI+ classes encapsulate some of the important Windows API to create graphical outputs. Popular GDI+ classes is needed for creating Windows applications. The system.drawing contains other namespaces for specialized applications such as system.drawing.imaging for image processing, system.drawing.design for design time controls such as dialog boxes, property sheets, etc. System.design.text for controlling fonts, system.drawing.printing for controlling printing and print preview. Example. Create a Windows application. Name the project GDI Test. Right-click on form1.cs in the Project Explorer and choose View Code. Type the following code in the constructor for Form1 class. Add a paint event handler by clicking on the lightning symbol above the Properties window and double-clicking on the paint event. Type the following code in it. Note that the paint event handler gets a DC through the paint event args parameter, so you can simply use graphics DC equals e.graphics to obtain the DC. The paint event args parameter in the paint handler also contains information about the clipping rectangle. The clipping rectangle is a rectangular area that needs to be repainted. This is similar to the invalidated region in MFC. The clipping rectangle becomes important when there are a large number of objects to be redrawn in the paint handler. Using the clipping region information, we can choose to redraw only a few of these objects which are being affected. Brushes are used to fill a particular region with a color or pattern. For example, the DC has a fill rectangle method and a fill ellipse method. You can pass a brush within the bounded rectangle to fill the shape with a brush. Case study: Chat program. The application is a simple chat tool. Anyone who connects to the chat server receives all chat communication between the connected users. The application is deliberately kept simple to clarify .NET remoting. This application also demonstrates event and delegate usage in an application that uses .NET remoting. Most of you will have noticed that there are wizards to develop ASP.NET Web Services in Visual Studio.NET. However, if you want to develop a client-server application that runs over a local area network, there are no wizards available. This application shows how to do a .NET remoting in a local area network. Chat Coordinator, the server implementation. Chat Client, the client implementation. Chat Server, the runtime host for Chat Coordinator. This application acts much like a DCOM server and client application. The Visual Studio.NET solution contains 3 modules. The following example illustrates Chat Coordinator. The server implementation. The following example illustrates Chat Client, the client implementation. The following example illustrates Chat Server, the runtime host for Chat Coordinator. Conclusion: in this chapter, the user would have learned about advanced features using C# and the following in detail: web services, Windows services, messaging, reflection, COM and C#, localization, distributed application in C#, XML and C#, unsafe mode, graphical device interface with C#, case study, messenger application.